So today we will solve the next paper of October-November 2022, 3-2. The first question is solve the equation 2 to the power 3x minus 1 is equals to 5 times 3 to the power 1 minus x. Give your answer in the form of ln of a over ln of b, where a and b are integers. Take ln on both sides. Ln of 5 plus ln of 3 power 1 minus x. Bring 3 minus x back, and then ln of 5 plus 1 minus x into ln of 3. 3x ln of 2 minus ln of 2 is equal to ln of 5 plus ln of 3 minus x ln of 3. Now combine all the terms involving x. So this will be 3x ln 2 plus x ln 3 is equal to ln 5. Ln 5 plus ln 3 will be ln 5 times 3. And then plus ln 2. This will be, now take x common. So I can write 3 in the power of 2 using the properties for ln, plus ln of 3 is equal to, this will be 15 plus ln 2. So x ln 2 to the power 3 is 8 plus ln 3 is equals to ln 15 times 2. So ln of 8 plus ln of 3 is ln of 8 times 3 by using the properties for ln. So this will become ln 24 is equal to ln 30. So x will be is equal to ln of 30 divided by ln of 24. Do not use the calculator because he was asking the exact answer in the form of ln of a divided by ln of b. Now our a is 30 and b is 24. Moving to the next question. The polynomial 2x cubed minus x squared plus a, where a is a constant, is denoted by p of x. It is given that 2x plus 3 is a factor of p of x. Find the value of a. If 2x plus 3 is a factor of a, if of p, we can put 2x plus 3 is equal to 0 to get the value of x, and this will gives us x is equal to 2 minus 3 by 2. Now put this value in the above polynomial. So 2 times minus 3 by 2 to the power 3 minus 3 by 2 whole square plus a is equal to 0. As 2x plus 3 is so this will gives us the remainder 0. So now this will be 27 divided by 8 minus 9 divided by 4 plus a equal to 0. Now a is my subject. So this will be minus 27 divided by 4 minus 9 over 4 plus a is equal to 0. So 27 plus 9, take LCM. This will be minus 27 minus 9 plus a is equal to 0. So this will become minus 36 over 4 plus a is equal to 0. And this will gives you a is equals to 9. When a has this value, solve the inequality p of x less than 0. Now p of x is actually our cubic polynomial, 2x cubed minus x squared plus a. So first let me write p of x. P of x is x cubed, 2x cubed minus x squared plus a. But now a is 9. So this is p of x. And I want to find the solution for P of x less than 0. Just remember the class of AS, that how did you solve a quadratic inequality there? But this time you have a cubic inequality, okay? So as he was saying that 2x plus 3 is a factor, so just start long division. So I can write 2x cubed minus x squared plus 9 here, and then 2x plus 3. If I multiplied with the 2x square, this will give me, sorry, just x square. This will become 2x cubed plus 3x square. This will be 0 minus 4x square plus 9. Then I will multiply with minus 2x. So this will become minus 4x square minus 6x. So this will be 0. 6x plus 9. Then I will multiply it with 3. So 6x plus 9. So the remainder is 0. So it means my cubic polynomial 2x cubed minus x squared plus 9 is actually the product of 2x plus 3 into the quotient plus remainder. And remainder is 0, so you don't need to write that. Now, this is less than 0. Now, just think that when the product of two brackets or two quantities is negative, there are two cases. Case number one is either this is negative and along with this, the other quantity will be positive. So first solve this, you will get x less than negative 3 by 2. So just plot this value on real line. So this will be minus 3 by 2. Okay. Now we have two portions, this portion and the left portion and the right portion. Now the left portion is true for this inequality. Okay. Now I will check whether this left portion is true for the other inequality or not. So take any number from the left side of minus 3 by 2. So I'm just taking, this is 3 by 2 is actually 1.5. I'm just taking x is equals to negative 2. And I will put this negative 2 in the other inequality. So this will become minus 2 square plus 4 plus 3 greater than 0. So this will be 4 plus 4 plus 3 greater than 0. So this will be 11 greater than 0. So this means that this side is true for both the inequalities. But I cannot check the right hand side because this right side is not true for the first inequality. So I will not check it. So it means that the left portion of left side of minus 3 by 2 is true for both the inequalities. So I can consider this as my solution. But we will discuss the second case as well. The second case is, let's suppose 2x plus 3 is positive, but the other quantity should be negative because the product is negative. So one of them should be negative. So this is the second case. Similarly, find this value of x from the first inequality and you will get x greater than minus 3 by 2. This time, this is minus 3 by 2. This time, this portion is true for the first inequality, this portion. Okay. So we will only check this portion for the other inequality as well. So it's very simple. Just check 0 because 0 lies in this interval. So just check 0 for the other inequality. This will give you 0 squared minus 2 times 0 plus 3 less than 0. So this means that 3 less than 0. So it's false. So it means that this portion, which was true for the first inequality, but it's not true for the second inequality. So it means that only we will discuss the only first case, and the answer for the first case is answer is x less than negative 3 by 2 only. Okay, this is the only solution for this cubic inequality. Okay, moving to the next question, the equation of a circle of a curve is y is equal to sine x times sine 2x. The curve has a stationary point in the interval. Find the x coordinate of this point, giving your answer correct to 3 significant figures. Now, while finding the derivative for this curve, you will apply the product rule. Okay. So apply the product rule. Dy by dx is equals to first function as it is, derivative of second, which is cos 2x into 2. So I will write 2. Then plus sine 2x as it is, and derivative of sine x, which is just cos x. Okay. So this is the product rule for this function. Now put this derivative equal to 0 to find the stationary point or the x coordinate of this point. Now there are different ways to solve this equation. The first way is to convert this whole equation to a single trigonometric function. Either you can convert this into the sine x, or you can convert into the cos x. So let me write first of all the formula for sine 2x. So if you apply sine 2x formula here, this will become 2 sine x cos x into cos x equals to 0. So 2 sine x cos 2x plus 2 sine x cos square x is equal to 0. While solving these type of equations, I'm writing a line here. Take maximum things common, at each step. Okay. So this is the step. You can take maximum thing common as 2 sine x. You can take common 2 sine x. So inside will become cos 2x plus cos square x equals to 0. Okay. I have just applied the formula of sine 2x. I did not use the formula for cos 2x. The reason was because sine 2x, if I open the sine 2x, I will again get a single term because it's the product of 3 things, 2 sine x and cos x. But if I use cos 2x, it will convert it to 2 different terms, either the sum of 2 terms or the product of 2 terms, So I will prefer to open first of all sine 2x so that it will not disturb my equation. Okay. Then I will apply, you always apply this concept while solving the derivative of trigonometric, the product of trigonometric functions. Okay. Please try to keep in your mind this sentence. Okay. So now put 1 by 1 sine x equal to 0, and then cos 2x plus cos square x equals to 0. So the first one will give you sine x is 0, so it means sine x can be 0 or pi. Both are not included in the domain. So leave this. Now you have this equation, cos 2x plus cos square x is equal to 0. It's very, very simple that now you have 3 formulas for cos 2x, but you can see that there is another function cos square x, and you have a formula for cos 2x which involves only cos x. So you will prefer this formula. So you will write 2 cos square x minus 1 plus cos square x equal to 0. This will be 3 cos square x minus 1 equal to 0. This will be cos square x is equal to 1 over 3. And now you will have cos x is equal to plus minus 1 over square root 3. Okay. You will discuss separately plus, and then cos x is equal to negative 1 over square root 3. Now cos x is positive in first and fourth quadrant, and cos x is negative in second and third quadrant. Okay. In both the cases, basic angle is shift cos inverse 1 over square root 3. The basic angle is 0.9553. Okay, in both the cases. Now the required angle is this one, which is actually the basic angle. So the first answer is only 0.9553, or you can just write it as 0.95 as a final answer, or the three significant figures. Sorry, the question was three significant figures needed, so the final answer will be 0.955. If you try the second case, so its basic angle is also 0.9553, but when you will find this angle, this will be out of domain. Okay, because your domain was 0 to pi by 2. Okay, but this value is greater than, this answer will be greater than pi by 2. So x is equal to 0.955 only. The fourth question is express 4 cos x minus sin x in the form of r cos x plus alpha, where you have to find the value of alpha and r. So just equate 4 cos x minus sin x equals to r cos of x plus alpha. Now apply the identity on the right side. So the identity was cos of x into cos of alpha minus sine of x into sine of alpha. Now compare the cos x and sin x. If you compare cos x, you will have 4 is equal to r cos alpha. If you compare sin x, you will have minus 1 is equal to minus r sine of alpha, or simply 1 is equal to r sine alpha. Okay, so 1 is equal to r sine of alpha. These are the two very important equations, because we have solved these type of equations in mechanics as well. Okay, the forces and equilibrium chapter. So call it 1 and 2. Now you will find r and alpha from this equation. Always square the first equation and then take square of the second equation. Okay, both sides, and then just add them. You will find 16 plus 1, and right side will be r square cos square alpha plus r square sine square alpha. If you take r square common, inside will be cos square alpha plus sine square alpha, and this is another identity which is 1, and left side will be square root of 17. So r will be square root of 17. Okay, now put r is equal to square root of 17 in equation 1. 4 is equal to square root 17 cos of alpha. Now you can find 4 over square root 17 is equal to cos of alpha. So just take cos inverse of 4 over square root 17. So calculator will be in radian. Shift cos inverse 4 over square root 17 17 equals. So the final answer will be 14.036. So I can write it as 14.04 degree. Okay, moving to the question, hence solve the equation. Hence solve the equation 4 cos 2x minus sine 2x is equal to 3 for 0 to 180 degree. Okay, This time, if you see the previous part, the equation was 4 cos x minus sin x. And compare this with part B. Here you have 4 cos 2x minus sin 2x. So expressions are same, but angles are different. Okay. So if I write the answer for first, the answer for first was 4 cos x minus sin x is equals to r, which is square root 17 cos of x plus 14.04 degree. Okay. The answer was 0.3630. But for second part, you can use it up to 4 decimal places. Okay. 14.0362. So I'm writing 0362 so that your accuracy will be maintained. This was the answer for the first part. But this time you have 4 cos 2x minus sin 2x. So you will replace the answer of the first with x will become 2x. Okay. 14.0362 degree. Now we need to find x. Okay. As this is equal to 3, so it's mean I can put this is equal to 3 because 4 cos 2x minus sin 2x is equal to this one. So square root 17 cos of 2x plus 14.0362 degree is equal to 3. So cos of 2x plus 14.0362 degree is equal to 3 over square root 17. Now, here you have the cos x positive in first and fourth quadrant. Okay. And now your domain is 180 degree. Your domain is 180 degree means your answer, your final answer will be in this domain. Okay. Now, if I find the basic angle for this will be shift cos inverse of 3 over square root 17. Okay. And shift cos inverse of 3 over square root 17. This will be 43.3138. 43.3138. Okay. This is my basic angle. So now possible answers can be this one and this one. Okay. So final answer, which can be my angle, which is 2x plus 14.0362 degree is equal to the basic angle 43.3138 degree. Do not go for the periodic functions. Okay. You cannot deal 100% with periods. So this is the another method. Okay. You can try all the answers and at the end you can see that which answer lie in your required domain. Okay. So solve this equation for x. So this will be minus 14.0362. Solve this equation for x. Okay. Divided by 2 to get the x. So x is 14.6388. Okay. So I can write it as x is equals to 14.6 degree. Okay, this is my first answer. Now, my second answer can be 2x plus 14.0362 degree, which is my angle. So my angle will be is equal to this whole angle, okay, which is actually 360 minus basic angle 3138. This is the best method, okay. You cannot ignore any answer if you apply this method, okay. This is quite a long method, but if you apply this method properly, you will never miss any answer, okay. So now solve this equation for x. So 360 minus 43.3138 and then minus 14.0362 and then divided by 2. This is your final answer. So x will be is equal to 151.325. So if you will write the final answer, you will write 151.3 degree. 151.3 degree. So these are the two possible answers, okay, which is 14.6 degree and the other one is 151.3 degree, okay, and both are in the domain 0 to 180 degree. Now the question 5. Solve the equation z square minus 6iz minus 12 is equal to 0. This is clearly a quadratic equation and you have a best method to solve this equation, and that is quadratic formula. Quadratic formula is minus b plus minus b square minus 4ac divided by 2a. So minus b is 6i plus minus b square, 6i square minus 4, a is 1 and c is minus 12, whole divided by 2 times 1. So minus 6i plus minus 6i square will be minus 36 plus 48, okay, divided by 2. So my final answer will be minus 6i plus minus, my final answer will be 48 minus 36, which will be just 12 over 2. So I can write it as minus 6i plus minus square root 12. You can find using calculator. This will be 2 square root 3. Okay. Now divide 2 on both the things. This will be minus 3i plus minus square root 3. So I can write it as 3 plus 3 minus 3i, comma, minus square root 3 minus 3. Okay. Now, on a sketch of an Argand diagram, with origin O, show that points A and B representing the roots of the equation in part A. I made a mistake here because my B was minus 6i. Okay. So if I put minus 6i here, so this will become plus 6i. So both are plus. Okay. Now, on an Argand diagram, you will represent these roots. Okay. So call a point A, which is 3, 3, and other point minus square root 3 with comma 3. Okay. And square root 3 is almost 1.7 something. 1.73. Okay. So now 1, 2, 3, 4, and 5, minus 1, minus 2, minus 3, minus 4, and minus 5. 1, 2, 3, 4, minus 1, minus 2, minus 3, and minus 4. Okay. The first point is square root 3, comma 3. So it's mean 1.73 on x-axis and 3 on y-axis. So almost here. And the other point, this is A, which is square root 3, comma 3. And the other point is B, which is minus square root 3, comma 3. This will be here, minus square root 3, comma 3. So here's your O. This is real part of Z. You will call it imaginary part of Z. Okay. Find the exact modulus and argument of each root. Now the first root was minus plus 3i and second was square root 3 plus 3i. So modulus for first will be, modulus of this will be 3 plus 9, which will be 12. And you can write it 2 square root 3. And the modulus for second will be again 3 plus 9, which will gives you 2 square root 3. Now argument for square root 3 plus 3i will be tangent inverse of this, because this is in the first quadrant. So tangent inverse of y over x, and argument of minus square root 3 plus 3i, as x is negative and y is positive. So this will be pi minus tangent inverse of 3 over square root 3. Okay. I think exact modulus and argument. So let me try. Shift tangent inverse of 3 over square root 3. This is 60 degree. And or 60 degree means pi by 3. And the second is simply 180 degree minus 60 degree. So this will be 120 degree. Okay. Hence show that the triangle OAB is equilateral triangle. Now equilateral triangle is whose all the sides are same. So if I join O with A and B, it means that all the sides are same. If I do calculations, tell me what is AB, the distance between A and B. It's clearly this distance is 2 square root 3 because this part is square root 3 and this part is also square root 3. So AB will be 2 times square root of 3. And again, if you find this distance, the modulus is actually the distance. Okay. The modulus of 3 plus 3i, which we did in the C part, the modulus of this is 2 square root 3, and again the modulus of the other complex number is also 2 square root 3. Modulus means the distance of A and B from origins. Okay, this is the definition of modulus. So you can see that all the lengths are same. So this is the equilateral triangle. So AB is equals to 2 square root 3. OA is equals to 2 square root 3, and OB is equal to 2 square root 3. So it's a equilateral triangle. So moving to the next part, relative to the origin O, the points A, B, and C have the position vectors given by this. Use a scalar product, find the cosine of the angle BAC. Okay. So draw a diagram you need to find this angle, okay, at A, and this is B, and this is C. Always try to find these two arrows, okay? So BA will be OA minus OB. So OA minus OB. 1 minus 3 is minus 2. 3 minus 1 is 2. And 1 minus 2 is minus 1. This is BA. And then CA. This will be OA minus OC. So OA minus OC, this will be minus 4, 0, and 3. Formula was BA dot CA is equal to BA magnitude, CA magnitude, cos of the angle between them. So find the cosine of the angle BAC. So it's mean we just need to find cos of theta, okay? Now take dot product or scalar product of BA and CA. So this will be minus 2, 2 minus 1 dot minus 4, 0, 3 is equal to the magnitude for first, that will be 4 plus 4 plus 1. Magnitude for second will be 16 plus 9 into cos of theta. So if you take the scalar product, this will become 8 plus 0 minus 3, and this will become 4 plus 4 plus 1 is 9, and this will become 3. 16 plus 9 is 25, and this will become 5 cos of theta. So 5 over 15 is equal to cos of theta. So cos of the angle between BA and AC is 1 over 3. Okay. So let's move to the next part of this question. Hence, find the area of the triangle ABC. Give your answer in simplified exact form. In most of the questions in vectors, while finding the area of the triangle, you will apply this formula 1 over 2 to any two sides into sine of angle between them. Okay, sine of angle between any two sides. So now we have already the angle. We have already the angle cos. Again, this was the here we have the diagram, and cos theta is equals to 1 over 3. So it's mean theta can be cos inverse of 1 over 3. So shift cos inverse 1 over 3. This will be 70.5288. 70.5288 degree. Okay. Now PA magnitude means length. This was, you can see here, this was 3. So length of BA is 3, and then length of CA is 5, and the angle between BA and CA is 70.5288 degree. So area will be 1 over 2 product of two sides into sine of angle between those two sides, 5288 degree. So put these values in the calculator. 15 over 2 times sine of 70.5288 So my area will be 7.07 degree, or you can write it, sorry, not degree. This is area, not the angle. So area will be 7.1. Okay. Next is, hence find the area of the triangle, give your answer in the simplified exact form. Okay. The question was, give the answer in exact form, and we have converted to the decimal. So it will be considered as wrong. So let us convert this answer to the exact form. This is also simple. As cos theta is 1/3. So let's say if you see the diagram, cos is this. So you can find P. So P will be 9 minus 1. So this will be 8. So P will be square root of 8. This will be 2 square root 2. Okay. So 2 square root 2. So it means sine of the angle will be, sine of theta will be 2 square root 2 over 3. So area will be equal to 1/2, 3 times 5 into sine of theta. And this will be 15/2 into 2 square root 2, because sine of theta is 2 square root 2 over 3. So final answer will be 5 square root 2. Okay. Moving to the next part. The variable x and theta satisfy the differential equation. X sine square theta dx over d theta is equals to tangent of square theta minus 2 cot theta. For 0 less than theta less than pi/2 and x is greater than 0. It is given that x is equal to 2 when theta is equals to pi/4. Show that derivative of cot square theta is equals to minus 2 cot theta divided by sine square theta. Now hint is already given. Hint says that you may assume without proof that the derivative of cot theta with respect to theta is minus cosecant square theta. Okay. It means that it's already given that derivative with respect to theta of simply cot theta will be minus cosecant square theta. This is the derivative of cot theta. Okay. So if you find the derivative of cot square theta, you will apply simple the power rule. You will bring 2 to the back and then apply the like nxn minus 1. Okay. 2 cot 2 minus 1 theta into the derivative of inner function, which is cot cotangent theta. Okay. Similar to cos square theta, we did so many times that the derivative of cos square will be 2 cos square theta, and then the derivative of inside that will be minus sine theta. Okay. So similar to this will be 2 cot theta into derivative of cot theta is it's given already in the hint, and this will be minus cosecant square theta. Now I can write it as 2 cot theta divided by cosecant square theta is actually 1 over sine square theta. So this is as required that derivative of cot square theta is equal to minus 2 cot theta divided by sine square theta. Okay. The next part is, this is the main part actually. Solve the differential equation and find the value of x when theta is equal to pi by 6. Now we will solve this differential equation, okay? We have also the condition when x is equal to 2, theta is equal to pi by 4. We will use this equation later on, this condition later on. And now you will solve this differential equation. First of all, write x dx is equal to tangent square theta minus 2 cot theta. Bring d theta on the right side and then divide sine square theta to the right side. Now integrate both the sides. The integration for left side will be x square over 2 is equal to integration of tangent square theta over sine square theta minus integration of 2 cot theta divided by sine square theta d theta. Further, if I write tangent square theta, I can write it as sine square theta over cos square theta and then whole divided by sine square theta minus d theta also minus 2 cot theta sine square theta d theta. So this will become, yes, this will become sine square theta over cos square theta times sine square theta d theta minus 2 cot theta divided by sine square theta. Okay, d theta, you can cancel this sign and this will become 1 over cos square theta d theta minus 2 cot theta over sine square theta d theta. Okay, now 1 over cos square is actually secant square theta, and you have the formula sheet in which the integral for secant square theta is given, and that is tangent of theta. Okay, minus. Now tell me how you will integrate this part. If you pay the attention to the first part was, in the first part, it is given that the derivative of cotangent square theta is equal to minus 2 cot theta divided by sine square theta. So it means if this is the derivative for this one, so it means integration of this part will gives you this function. We have studied this concept for so many times, so I'm just using it directly here. So first of all, bring this minus inside like this and write plus outside the integral. Then plus, what is the answer for this part? This will gives you cotangent square theta, because the derivative of cotangent square theta is the minus 2 cot theta divided by sine square theta. So it's simple. Then plus constant of integration. Here you have x square over 2. This is the final integration. Now the condition was x is equal to 2 when theta is equal to pi by 4. At start you can see. So 2 square over 2 is equal to tangent of pi by 4, which is 45, plus 1 over tangent of 45 whole square plus c. Now, as you know that tangent of pi by 4 is actually tangent of 45, and you can use the calculator. This will gives you tangent of pi divided by 4 will be 1. If you convert into the radians, this will be 1. So this means right side will be 2 is equal to 1 plus 1 over 1 plus c. So 1 plus 1 is 2. 2 is equal to 2 plus c. So it means c is equal to 0. Okay. Now solve the differential equation and find the value of x when theta is equal to pi by 6. So now put c here, x over 2 is equal to tangent of theta plus cot square theta, okay, plus 0. Just put c is equal to 0 here in this part, okay. So now put theta is equal to pi by 6 to get value of x. Find the value of x when theta is equal to pi by 6. So x square over 2 is equal to tangent of pi by 6 plus 1 over, or tangent is actually 1 over tan. So 1 over tan pi by 6 square, then tangent of shift pi divided by 6. So tangent of pi by 6 is square root 3 over 3. Square root 3 over 3 plus 1 over square root 3 over 3, then it's square. This will become square root 3 over 3 plus 1 over 3 over 9. This will be square root 3 over 3 plus 9 over 3. That will be square root 3 over 3 plus 3. So x squared is equals to 2 times square root 3 over 3 plus 3. Now take the square root, take LCM also. Now take the square root of this. So now the square root of square root 3 plus 9. If you find any mistake in this paper, you can send me in comments. You can tell me in comments, and then the answer is x is equals to 2.67. This is the value for x when theta is equals to pi by 6. Okay. Moving to the next part. The next question is question 8. The diagram shows part of the curve y is equal to sine square root x. This part of x, the x-axis at the point where x is equal to a. State the exact value of a. If it's intersecting with x-axis, it means its y is 0. So put y is equal to 0. Sine square root x is equal to 0. This means that if sine theta, suppose if sine theta is 0, it means theta is either 0 or pi or 2 pi or 3 pi and so on. Any pi, sine of that angle will be 0. So it means x square root x is equal to either 0 or pi or 2 pi or so on. Okay, but it cannot be 0. So square root x is equal to pi, so x will be pi square. Next, is use the substitution. U is equal to square root x. Find the exact area of the shaded region in the first quadrant bounded by this part of the curve and the x-axis. Now area is equals to 0 to pi square, because this is the value of a, and then the function, and then dx. Now the substitution is given. Substitution is u is equal to square root x. Take its derivative. Du over dx is equals to 1 over 2 square root x dx. So du is equal to 1 over 2 square root x dx. Okay. Now as square root of x is equal to u, So it means that du is equal to 1 over 2u dx. So cross multiply to get the value of du completely in the form of u. This was the first step. The second step was the limits. Now, if x is equal to 0, then u will be is equal to square root of 0, which is 0. If x is equal to pi square, u is equal to square root of pi square, which will be pi. So this means that area will be is equal to 0 to pi sine of square root of x is actually u, dx becomes 2u du. Okay. So if you see, you will solve this integral using which of the following technique? By parts or any other method? Tell me. So preferably by parts will work here. So now integrate it using the by parts integration. So I'm considering 2 inside. So this will be considered in the as a u, means in the derivative, and sine u will be taken in the integral. So 2u integral of sine u minus derivative of 2u, which is 2, integral of sine u du, then again du. This will be 2u. The integral of sine u is minus cos u minus 2 will come outside. The integral of sine u is minus cos u. So inside will become plus, then cos u. So minus 2u cos u plus the integral for cos u is simply sine u. Okay. Now apply the limits. Minus 2u cos u plus 2 sine of u 0 to pi. So this will become minus 2 pi cos pi plus 2 sine pi minus 0 plus 0. 2u cos u will become 0 if you put 0, and sine 0 is also 0. Now this will be minus 2 pi cos pi is minus 1 and sine pi is 0. Okay, this will also 0. So net result will be 2 pi. Okay, area will be is equal to 2 pi. Question 9 is, the diagram shows a semicircle with diameter AB, center O, and radius R. The shaded region in the minor segment on the chord AC, and its area is 1/3 of the area of the semicircle. The angle CAB is theta radians. You can see that this triangle OACO, this triangle is actually a very well-known triangle. Isosceles triangle, it means that its base angle will be same. So if this is theta, so this will also be theta. As the sum of internal angle of a triangle is 180 or pi, so this means that this remaining angle will be pi minus sum of two angles. Okay, so this remaining angle will be pi minus 2 theta. Now we will target this shaded area. Shaded area can be found using, first of all, find the area of the sector, area of sector AOAC, which will be 1 over 2 r square theta. This is the area of the sector AOC. And then area of triangle. Area of triangle AOC. Again, this will be 1 over 2 product of adjacent sides into angle between them. Now we'll find sine of pi minus 2 theta using the identity sine alpha cos beta minus cos alpha into sine beta. So sine pi is 0, cos theta, cos 2 theta will become 0 minus cos pi is minus 1 into sine 2 theta. So eventually the final answer will be sine 2 theta. Okay, so this means that area of triangle will be 1/2 r square into sine 2 theta. Okay. Now the shaded area will be the area of the sector minus area of the triangle. This is the shaded area. As this shaded area is 1/3 of the area of the semicircle, so this means that this is equals to 1/3 into area of semicircle. So now you can cancel in these type of questions, this constants will cancel out. Okay. So what I will do, this will become pi by 2 minus theta minus 1/2 sine 2 theta is equals to pi over 6. So you can see the answer as well. Now theta is our subject actually. Now theta is our subject. So make theta as your subject. Pi by 2 minus pi by 6 minus 1/2 sine 2 theta is equal to theta. So pi by 2 is 90 and pi by 6 is 30. 90 minus 30 is pi by 3 means 60. 1/2 sine 2 theta is equal to theta. This is the required form. Okay, theta is equals to 1/3. You can take actually common. You don't need to take common, but if you want to make exact form, then you will have to take common. 1/3, when you will take 1/3 common, this will become 3/2 sine 2 theta, and 3/2 is actually 1.5. So 1/3 pi minus 1.5 sine 2 theta. This is the required form. Okay. Now verify by calculation that theta lies between 0.5 and 0.7. It means you need another function by bringing all the things on the left side. So theta minus 1/3 pi minus 1.5 sine 2 theta. So put theta is equal to 0.5 and then theta is equals to 0.7. But for this, first of all, set your calculator on radians, and it's already on radians. So 0.5 minus 1/3 pi minus 1.5 sine of 2 times 0.5. Negative 0.126 and then 0.7 0.7. This will give you 0.14145. So this is positive answer and this is negative. If signs are changing, so this means that theta lies between 0.5 less than theta less than 0.7. As signs are changing. So now use an iterative method . Use an iterative formula Based on the equation in part A, to determine theta correct to three decimal places, given the result of each iteration to 5 decimal places. So copy this answer. Set the iterations. Theta n plus 1 is equal to 1/3 pi minus 1.5 sine of 2 theta n. Okay. And theta naught can be chosen as the average of 0.5 plus 0.7 divided by 2. The average of this will be 1.2 over 2, 0.6. Then put n is equal to 0. You will get theta 1, which is equal to 1/3 pi minus 1.5 sine 2 times theta naught. So use the calculator now. 1/3 into pi minus 1.5 sine of 2 times theta naught, which was 0.6. Then again bracket close, that's equals to 0.58118, because you need to give each iteration up to 5 decimal places. Okay. Now replace 0.6 with the answer, and then keep pressing equal. You will get 0.58833. Then again press equal. You will get theta is equals to 0.58553, and then press again equal. You will get theta 4 is equal to 0.58661. Then again press equal. You will get theta 5 is equals to 0.58619. And then press again equal. This will be theta 6 is equal to 0.58635. So up to 3 decimal places, if you see that this value, this value will be 0.586 up to 3 decimal places for both theta 5 and theta 6. So it means that my final answer will be 0.586 up to 3 dp. Okay. Next question is, let f of x is equals to 4 minus x plus x square divided by 1 plus x plus into 2 plus x square. Now you need to convert this expression to the partial fraction. Okay. Now this is case number 3. So write this a over 1 plus x plus bx plus c divided by 2 plus x square. Now take LCM. 1 plus x into 2 plus x square, a times 2 plus x square plus bx plus c times 1 plus x. So now you can cancel these brackets, and finally you will have 4 minus x plus x square is equals to a times 2 plus x square plus bx plus c into 1 plus x. So also multiply this equation. This will be bx plus bx square plus c plus cx. Okay. Further, put x plus 1 equal to 0. This will gives you x equals to minus 1. Put this value above. This will become 4 minus minus 1 plus minus 1 square. And right side, on the right side, you will put in this equation. Okay. This equation will become 0 because of that. Because of x plus 1. So a times 2 plus minus 1 square. So this will be 4 plus 1 plus 1 is equals to a times 2 plus minus 1 square is 1. So 3a. So 6 over 3 is equal to a. So this means you will have a is equal to 2. Now you will compare the coefficients. So if you compare the coefficient of x square, left side is 1 is equals to a plus b. So 1 is equals to 2 plus b. So b will be is equals to minus 1. And if you compare the coefficient of x, then left side you will have minus 1 is equal to, on the right side you will have bx, sorry, just b plus c. So minus 1 is equal to minus 1 plus c. So minus 1 will be cancelled out. So finally you will have c is equal to 0. So when you will put these values above, so this will take the form 1 plus x, 2 over 1 plus x, plus b is minus 1, x plus 0 divided by 2 plus x square. So I can write it as 2 over 1 plus x minus x over 2 plus x square. So this is the final answer. The next is find the exact value of the integral from 0 to 4 f of x d of x. Give your answer as a single logarithm. Now, please do not forget this word as I did in some previous question, exact value. Okay, you don't use calculator in this. So now you will integrate this function, the 2 over 1 plus x minus x over x square plus 2 d of x from 0 to 4. Okay. Now, you have studied the formula that if you have a derivative in the numerator and a function whose power is 1 in the denominator, then its integral will be just ln of the function which is in the denominator. So you will apply this formula on the second integral and first as well. So the first integral is so easy. This will be just 1 over x plus 1 dx 0 to 4 minus. For second integral, you will have to multiply and divide with 2 so that the derivative of denominator will become in the numerator, will be showing in the numerator. So first integral will become 2 of ln of x plus 1 minus 1 over 2 ln of x square plus 2. Then whole bracket, limits from 0 to 4. Then put above limit. So 2 ln of 4 plus 1 is 5 minus 1 over 2 ln of 4 square is 16 plus 2 is 18. This is the upper limit minus lower limit. 2 times ln of x is 0, so ln of 1 minus 1 over 2 ln of 2. So you can write it as ln of 5 square minus 1 over 2 ln of 18 minus 2 like this will be 0. This will become 0 minus 1 over 2 lean 2. So lean 25 minus 1 over 2 lean 18 minus plus 1 over 2 lean 2. So first of all, take 1 over 2 common from the second two, from these two leans. So this will become lean 2 minus lean 18. So I can write it as lean 25 plus 1 over 2 lean 2 over 18. So this will be lean of 25 plus 1 over 2 lean of 1 over 9. Okay. So further I can write it as lean of 25 plus, you can bring this 1 over 2 in the power, and then this will become the square root. So lean of 25 plus lean of like square root 1 over 9. So this will become lean of 25 plus lean of 1 over 9. So simply lean of 25 times 1 over 9. So this will become lean of 25 over 9. This is the simplest form of, sorry, this is not the 9 because the square root of 1 over 9 is 3. So here you have 1 over 3. Again, this will be, 1 over 3. So the final answer will be lean of 25 over 3. So we are end with this paper. Inshallah, in the next video, we will start the remaining paper of October-November 3 pure mathematics 3. So we'll see you in the next video.